learners over there. Okay, my dear learners over there, I greet you once again. This is your teacher Hakim. In this lesson, we are now going to visit what we call number system. We are going to look at what we call number system. Now, under number system, what is a number? We have two words there. We have the numeral and a number. So a numeral, it is a symbol of a quantity. So a number means quantity, how much something is, how many things are we getting that? So that how many, and you say there are two, then how do you write it? Two, you write it like this. Now this way of writing it two, it is a numeral, then this two is a number. So number means quantity or amount of something. Then in numeral, how do you represent that something? Okay, so we are going to look at number system, but under number system, we are going to look at what we call patterns and sequences. We are going to look at the patterns and sequences or sequence. How do these numbers, how do they relate? How are they related? How do we use them to form others? So that is the number pattern or the number system we are going to look at today. So a number system, number systems are different types of numbers we use. So in simple terms, a number system, so this is a different, or it is a different, or there are different systems, or there are different types of numbers we do what we use, and there are very many systems. So let us get some examples of number system. So our first number system here, we are going to look at what we call natural numbers. We are looking at what we call natural numbers. Right now, what are these natural numbers? So these natural numbers are the numbers that we use for counting. So natural numbers are same as counting numbers. So when we are counting things, we can't say this is a 0 chair, 1 chair. No, we start from 1, 2, 3, 4, 5, 6 continuously. So those are what we call natural numbers, and the first natural number is a 1. Now what is the pattern? What is the pattern? How do these natural numbers get formed? So when you look at the pattern here, they are getting they increase by a 1. So from 1 to go to the next number, you add there another 1, you go to a 2. Now from 2 to go to the next number, you add there another 1, you go to a 3. Then from 3 to go to the next number, you add there 1, you go to 4. Now this is what called a number pattern. So they increase by adding a 1. So those ones are called natural numbers, my dear learner. These natural numbers are same as counting numbers. They are same as counting what? They are same as counting numbers. So natural numbers are same as counting what? They are same as counting numbers. Very, very fine. Okay, so we have looked at that one system. Then we have another system. We have a system of what we call whole numbers. A system of what? The system of whole numbers. So whole numbers are these numbers which we can also use in counting. So they are similar to counting numbers, or they are similar to natural numbers, but the difference is they start from a 0. So whenever you see this set 0, 1, 2, 3, 4, you just get to know that these are whole numbers. Whole numbers, the whole 0. Are you getting that? Then the whole 1. So that is all those are the whole numbers. So their pattern is also a 1. They increase by a 1. So you add 1 to 0, you get 1, 1 to 2, 1 to 1 to get a 2, 1 to 2 to get a 3, 1 to 3 to get a 4, 1 to 4 to get a 5, 1 to 5 to get a 6. So those ones are what we call the whole numbers. Are we there? But the difference between whole numbers and counting numbers or natural numbers is that the whole numbers, they start from a 0. We have another system in numbers, that is anchovy, and these ones are what we call the even numbers. These ones are called even what? They are called even numbers. Now what are these even numbers? So these are the numbers that, these are the whole numbers actually. These are whole numbers which are completely divisible by a 2. So which are completely divisible by a 2. So whole numbers are numbers that are completely divisible by 2. So we can divide them. For example, if I choose one whole number like 2, 2 divided by 2, I get 1 remainder 0. So they are completely divisible by a 2. So they don't leave any remainder, or they leave 0 as a remainder. Are we getting that one? Now, how do we get these whole numbers? I mean, examples of even numbers. The first even number is a 0. Because 0 divided by 2, you get 0 remainder 0, so you get no remainder. Now we go to a 2, then a 4, we go to a 6, then an 8. Now let us see how do we get these even numbers, right? How are these even numbers are formed? Now when you are getting these even numbers, when a whole number is multiplied by a 2 or doubled, you get an even number. You get this one. When a whole number is multiplied by a 2 or it is doubled, you're not doubling, meaning that 2 of 1, this is doubling. Are you getting that? So if we multiply it by a 2 or we double it, then we are getting an even what number. Let us get one whole number. We said whole numbers, they start from a 0. When you multiply this one by a 2, you are getting a 0. That means this is an even number. Are we there? Now if we get the second whole number, what is that one? 1. You double it or you multiply it by a 2, you are getting a what? A 2. You go to a 2 times a 2, we are getting a 4. Then the whole number being doubled, we get a 6. Then a 4 double rate, we get an 8. Then a 5 double rate, we are getting a 10. So all these answers we have obtained are the even numbers, my dear learner. We've said, how do we get even numbers? We get even numbers by multiplying a whole number. By multiplying a whole number by a 2. If you don't say multiplying, you can say doubling a whole number. Doubling means do it 2 times. Are you getting that? So those ones are the odd numbers. So let us first get a simple order of even numbers. Here we have a 0, we go to a 2, a 4, 6, 8, 10, 12, 14, 16, 18, and so on. Are we getting that? Now we should note that we keep on adding 2 to get other next or subsequent even numbers in, because the pattern in even numbers is of what? Of a 2. If we are now getting the sequence here by adding a 2, they added a 2, they added a 2 to get this one, they added a 2 to get 8. Are you getting that? So those are the even numbers. Then again here we are going to look at another system. System 4. This is the system of odd numbers. The system of odd what? Of odd numbers. Now these are the whole numbers which are not completely divisible by a 2. So these are whole numbers. They are whole numbers, as we said whole numbers, they start from a 0. So they are whole numbers, but they are not completely. So for them, they are not completely divisible by a what? A 2, meaning that they give a remainder or they leave a what? A remainder. Now when you divide them by 2, you get a remainder of a 1. So these odd numbers end with digits like these odd numbers, they end with digits like a 1, a 3, a 5, a 7. Are you getting that? And a 9. So whenever you see any number ending with this one, you will just get to know that that is an even, I mean that is an odd number. If I have 42 and 43, so this one is an even, I mean this is an odd number, this one is an even number. So for them, they end with either a 1, a 3, a 5, a 7, or a 9. Now let us get the order of these odd numbers. So the first odd number is a 1, then we go to a 3, then there is a 5, then from a 5 we are going to get 7, then 7 we have a 9, 9 gives us 11, 11 gives us 13, 13 gives us 15, 15 gives us 17, 17 19, 19 21, 21 we go to 23, then 23 25. Are getting, and so on and so forth. So this is a set of the odd number. But there is a point you should remember, my dear learner. Factors are the two numbers multiplied to get another number. Factors are two numbers multiplied to get another number, e.g. 2 and 3. When you multiply them, you are getting another number. Let us go to another system, and this system is a system of prime numbers. So there are these numbers which we call prime numbers. Now what are these prime numbers? These prime numbers, this is very simple. These prime numbers are the numbers which have only two factors. These are numbers which have only two factors, and we said a factor, these are the two numbers which you can multiply to get another number. Two numbers which you can multiply to get another number. So these prime numbers, they have only only two. They have only two factors, one, and the number is off. One and the number is off. And some people try to confuse prime numbers with odd numbers. Now let us first see the first prime number. The first prime number, it is a 2. Then from a 2 we go to 3, then 5, then 7, we go to 11, we have 13, we have 17, 19, 23, we have 29, and so on. Now when we look at this, some members there, from there they were guessing the next one here to be a 9. Oh gosh, 9 is not a prime number, because if we said a prime number, we get it by multiplying only two numbers which we have called factors. So there is no any other number which you can multiply to give you prime numbers. For example, 1 and the 2 is off, you get a 2. But again, when you have 1 times 9, you have to get 9. So the first factor is to be 1, another factor is to be that number, it's off. But then now when you look at this 9, we can get other numbers like 3 times 3, giving us 9. Then when you look at 15, it is 1 times 15, it is 15, fine. But again, 3 times 5, I'm getting 15. Therefore, these numbers are not prime numbers. Why? They have more than one factor. Am I understood there? And now these prime numbers, for them, you have to just understand them. They don't have a regular pattern which we use to do what? To get them. Are you getting that? Now let us go and get another number here, another system of numbers. So this system of numbers here, it is a system of what we call composite numbers. This is a system of what we call composite numbers. Now the opposite of composite numbers, it is the prime number. So meaning that the opposite of prime numbers is the composite number. If you have said that prime numbers, they have more than they have only two factors, it means that now composite numbers, these are numbers with composite numbers are numbers with more than two with more than two factors. So these are composite numbers. So the numbers with more than two factors are with there. So composite numbers are numbers that have more than two factors. So it is the opposite of prime numbers. So we should note that composite numbers are numbers with more than two factors. So to get the next composite number, you use the fact of composite numbers having more than two factors. That's the fact we should use. For example, if we let us first list the whole numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Now we are going to choose what we call composite numbers. Now this one, no, it's not a composite number. Non-composite. This 4 is the first composite number. This is not composite. This one is composite. This one is not. This one is composite. Then this one is not. This one is. Then this one is also. This one is not. This one is. The 12 is. Then 13 is not a composite what number. So those are what we call composite numbers. 4, 6, 8, 9, 10, 12, 14, 14, 15, 16, and so on. So those are what we call composite numbers. So from composite numbers, let us look at this other number here, and these are what we call square numbers. So square numbers, let us look at what we call square numbers. Now what are these square numbers? So these square numbers are numbers got by multiplying a number by itself or squaring a number. So these are numbers got or obtained by multiplying a number by itself, the number itself. Or squaring the number. For example, 1 times 1 we get a 1. Now this one becomes a square number. Then 2 times 2, it is giving us a 4. This one becomes a square number. Then 3 times 3, this one becomes a square number. Or you can just say 1 squared. This means 1 times 1. So it can be 2 squared, which means 2 times 2. Or 3 squared, which means 3 times what? Times 3. 4 squared, which means 4 times what? 4, which is 16. Then 9 squared, which means 8 times 8, 9 times 9, which is giving us 81. Then 10 squared, which is 10 times 10, which is giving us 100. Then 11 squared, which means that 11 times 11 is giving us 121, and so on and so forth. Now those are square numbers. So even apart from now squaring them like this one, we can also get these square numbers by adding consecutive odd numbers from 1. By adding consecutive odd numbers from 1. Now let us first get our odd numbers. Now our odd numbers 1, 3, then from 3 have a 5, then 7, then 9, then 11, then we have 13. I think 13. Then we have 13. Then we have what? 13. We go to 15. They are odd numbers. Now we start with the 1. Now 1 plus 3, we are getting a 4. Are you getting that? Then 3 plus 3. Now we are adding consecutive odd numbers. Now we have 1 plus 3 plus 5. This is when you add this one, this is 8, we get a 9. I think that. Now from here we add 1 plus 3 plus 5 plus 7. Now this is 9, 10, 11, 12, 13, 14, 15 and 16. I think that. Now we can get 1 plus 3 plus 5 plus 7 plus 9. Now 16, we are getting 25. I think. Now from there we can add 1 plus 3 plus 5 plus 7 plus 9 plus 11. Here we are getting 36. Then we have 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13. We are getting 49. So when look at this pattern, it is what we are getting what we call that the square numbers. Apart from squaring them like this one, we can also get them by adding consecutive odd numbers. Are we there? Is that one understood? Or you can get this sequence like this. We can get 1, 4, then 9, 16, 25, 36 and 49. Now from here to this, they have added a 3, which is this one. Now from a 4 to 9, they have added a 5, meaning that 1 plus 3 plus 5. I think this one. Now from there we have added 7, 9, 10, 11, 12, 13, 14, 15. I think so. We keep on adding 3, 5, 7, 9. Now from here we are going to add 9. Then from 9 we are going to add 11. Then from 11 we are going to add 13. I think that. So we are getting them by adding consecutive odd numbers. Are we there? Are we still together, my dear learners? Okay, now when finding, you have to take this note. When finding numbers in the sequence 1, first identify if the sequence is of any type of numbers, and if they are follow the first working of that particular type of numbers. So we need to get a sequence. In which sequence did they form these numbers? So what we have to do first is to identify, are these numbers of any of the systems given? If yes, now we should follow how do we increase how do those numbers increase in that pattern. Now after that, if the sequence is ascending order, you need to either add or multiply to get the next number if the sequence is in descending order, you need to either subtract or divide to get the next numbers. Prime numbers and composite numbers have no pattern. Now what I mean is this. Now they can give us a sequence in ascending order, like 1, then 4, and then like 4, then we go to a 9, then you go to maybe something like 16. Now when you look at this one, the series are increasing, so they're increasing, so they're in ascending order. Now when the series is in ascending order, we either add or multiply. We can add something onto this one, or we can multiply to get the next number. But again, they can give us a sequence when it is 16 going to 9, going to 4, going to 1. Now here, when it is reducing, which operations are reducing operations, we can either subtract or divide. Please learners, take note of this one. If they give you a sequence from a bigger number to going down, that is decreasing, descending, then we either subtract or multiply. But when it is from the smallest going to the biggest, then we either multiply or add. But remember, prime numbers, they don't have a pattern. Prime numbers, they don't have a pattern, as well as the composite numbers. Right, now you do for me this activity. Let us look at this exercise. Now exercise here, they're saying list number 1, list the following numbers. List the following numbers between 10 and 20. So here numbers should be listed in a set. In a set, what I mean, like 1, 2, like this one. That's what I mean. Not doing a Venn diagram and not like that. So part A here, counting numbers. So counting numbers between 10 and 20. Between counting numbers here. Then B here, we have odd numbers between 10 and 20. C, we have even numbers. Then D here, prime numbers. Then B, C, D, E, you list the composite numbers between 10 and 20. Composite numbers. E, then F here, we get square numbers. The number 2, find the next number in sequence. The next number in sequence. So here sequence is 0, 2, 4, 6, 8, 10. The next number. B, 17, 15, we have 13, 11 dash. Then C, 1, 2, 4, 7, 11, 11 dash. B, C, D, 2, 4, 7, 12, 19 dash. E, we have 21, 18, 14, 9. F, that is 1, 3, 4, 6, 7, 9. 1, 2, 4, 5 and 7. 5, 7. Let us get another one here. Number part F, H, I here we have 1, 4, 9, 16, 25, 36. J, 2, 3, 5, 7, 11 and 13. So those ones are that has been our activity 1 within these numbers. So in the next lesson we shall look at other numbers, as in consecutive, counting, triangular, and cube numbers. We meet in the next lesson.